Hi everybody. For this mini lecture, we are going to talk about research design, and then we're going to talk about how your research design has implications for the quality of your study, the rigor of your study, and how specifically when we talk about the quality of our study that results from a research design, we talk about it in the way of internal and external validity. So those are the major things we're going to talk about. Again, different research designs and then how those research designs impact our internal validity and our external validity. We will start off by just looking at the different research designs. So when we think about research designs, they really are the blueprint for our study. Based on the purpose of our study, whether it's explanatory or whether it's about an evaluation study, we determine based on that purpose what type of research design we need to use to accomplish that purpose. When we think of research designs, there really are three main levels of research designs, and they are listed on this slide from least rigorous to most rigorous. So the least rigorous type of research design that you could use in an explanatory or an evaluation study is a pre-experimental design. So with a pre-experimental design, you are still looking at the influence of a variable on another variable, or more than one variable on more than one other variable. So you're still looking at the impact of one variable on another. However, the design is not quite as rigorous as it could be. With a pre-experimental design, and we'll look at some examples of specific types of pre-experimental designs here in just a second, but with pre-experimental designs, you will have the lowest level of external and internal validity. You will most often have no control group. And when there is a control group, there's no random assignment. So there's a couple of terms just in that box that we need to go over. So in this box, I'm saying that if it's a pre-experimental research design, that you're going to have low internal and external validity. We're going to go through these terms again later on in this lecture. However, your internal validity refers to the ability of your study to really show that your independent variable is having an impact on your dependent variable. So in other words, how confident are you that it is your independent variables that are causing the change in your dependent variable, and that it's not some other extraneous factor, that there's not other outside variables that are having an impact on your dependent variable. So a study with high internal validity, that means that you feel very confident that the changes in your dependent variable were in fact caused by your independent variable. External validity, on the other hand, means that you feel very confident that your findings can be generalized beyond your sample. So your findings aren't just true for your sample, they are true for the larger population from which your sample was drawn. That's external validity. And again, I'll go through both of those terms again later on. So a pre-experimental design has the lowest level of external and internal validity. Then the next bullet that you see right here says that most often pre-experimental designs do not have a control group. So a control group just means that aside from having your intervention or your treatment group that is receiving the intervention, you also have another group of people who you're also giving a pre-test and or a post-test to, but they are not getting the intervention. So that's your control group. And then the other term that's here in this third bullet is that there is no random assignment. Where's my mouse? There it is. So there's no random assignment. Random assignment means that if you have a control group and you have a treatment group, that then people, your participants, are randomly assigned to one or the other. So they're either randomly assigned to your control group or your treatment group. That's what random assignment means. So again, a pre-experimental design, in those cases, you have the lowest level of internal and external validity. You usually don't have a control group. And if there is a control group, there's no random assignment to the control and the treatment group. Then the next level up of research designs is quasi-experimental. Quasi-experimental research designs have some external and internal validity, so it's a little bit better. Most of them have a control group, but there is no random assignment. So again, you have an increased level of internal and external validity for quasi-experimental designs. Most of them do have a control group, but there's no random assignment. So that's kind of the middle level of research designs. And then the most rigorous types of research designs are experimental research designs. Experimental research designs have the highest level of internal and external validity. They are the most rigorous. All of them have a control group, and there is always random assignment. So in order for a research design to be considered experimental, you have to have a control group and you have to have random assignment. Those are the two basic requirements for it to be an experimental research design. Again, so this shows you three types of research designs, three groups of research designs, pre-experimental being the least rigorous, quasi-experimental being in the middle, and experimental being the most rigorous. Now we're going to go into more detail about each of those. So I'm going to give you specific examples of research designs in each of those three categories. Okay, so starting with pre-experimental research designs. Again, these are your least rigorous, so they would be the easiest to carry out, the least resource intensive to carry out. The most common type of pre-experimental research design is this very top one. The one group pre-test, post-test design is the most common pre-experimental design that you'll find in published articles. In this case, and again, these O's and X's may be a little intimidating at first, but don't let them be, because all this says is O1 means observation 1, or another word for that would be pre-test 1, or pre-tests. And then X is your intervention, and then O2 is observation 2. So what this means is that O1, that's your pretest that you give people. After they've completed the pretest, then they get the intervention. After they've gotten the intervention, you're going to do a post-test. That's all those O's and X's mean. So the O represents observation, or a survey that's being administered, or some type of a focus group, etc., some way of collecting data. X is your intervention, and then O2 would be the post-test. So again, the one group pre-test, post-test design is probably the most commonly used type of pre-experimental design. The good part about having that type of a design is that at least you have that baseline that you collect with your pre-test, so you have an idea of how people are doing at pre-test, and then you have an idea of how they are doing at post-test after they've received the intervention. And that's really important, because if we don't have that, if we only have a post-test, then we don't even know where people started. So let me give you an example. Let's say I wanted to start up a smoking cessation program. And I wanted to see how my intervention helped people to reduce their smoking habits, to reduce the number of cigarettes they smoke in any given day. So let's say I only had the intervention, my smoking cessation session, and I had a post-test. Let's say I did not give a pre-test at all. So let's say I used this second research design, the one group post-test only design. And so I give my intervention, and then I measure the number of cigarettes that they're still smoking every day. And let's say the average number of cigarettes that's still being smoked in any given day is 6. Well, how do I know if that 6 is a good number or a bad number? How do I know if my intervention was effective or not? I really wouldn't have any idea, because I wouldn't have baseline data. I wouldn't know how much on average they were smoking before my intervention. At least if I have a pretest, then I could say, okay, the average number of cigarettes they're smoking at pretest is, let's say, 12. And then we give them my intervention, and then after my intervention we do a post-test, and what I find out is they're only smoking on average 6 cigarettes. So that, in and of itself, would suggest that my intervention was effective, that the number of cigarettes being smoked went down from 12 to 6. So that would show, intervention's doing a good job. Now that being said, it doesn't necessarily rule out other factors that might be influencing their smoking habits. I don't know what else is going on outside of their life, outside of my research in their lives that may be impacting the amount of cigarettes they're smoking. But at least I know from pre to post test there was a positive change in their smoking behaviors. So as you can see, just based on that example, using a post-test only design like this as indicated in the second bullet where you just have the intervention and then a post-test, that's really not quite as effective as the top one. Because in that second option, the one group post-test only design, you really don't know what the pre-test baseline data was. Now, if you have a sample of people who might be very hesitant to give you a name or another identifier, then you could use a post-test only design with non-equivalent groups. So that's the third option here. So you, again, don't administer any pre-tests. You just have your intervention and a post-test within your treatment group. And then you have a second group, a control group of people that also just take the post-test. You can use this, this non-equivalent groups design if you have people who are unlikely to be willing to give you their name or another identifier that would allow you to match up their pre and their post-test. Because if we look at this one group pre-test, post-test design, that requires us to be able to match up the people from pre-test to post-test. So they have to give, at a minimum, an identifier that allows you to match up their pre and their post-test. In the post-test only design, if you have people, like for instance you're working with inmates, they might not feel comfortable giving you identifying information. They might want to be completely anonymous. If that's the case, then you could just do post-test and have a control group that also takes the post-test. And that way you can use this control group post-test data as a comparison group, if you will. Again, it's not ideal, but in some circumstances where anonymity is very important, this could be a useful backup option. Okay, so these again are the main pre-experimental research designs out there. Again, the most common one that you'll see in articles that are published are this one group pre-test, post-test design. So that is something that's important for me to point out, is that even though pre-experimental research designs are the least rigorous of the types of research designs, articles still get published that use this type of research design very, very commonly. So it's very common for articles to be published that use pre-experimental research designs. Even though it is the least rigorous, it is very, very commonly used. Okay, then we're going to move on to quasi-experimental. So for quasi-experimental, as I mentioned before, oftentimes they do use control groups, but there's no random assignment in quasi-experimental studies. So the three most common ones, and I'll mainly talk about this top one, the non-equivalent control group design is really the most commonly used quasi-experimental design. So you have a treatment group, you have a control group, so the treatment group gets a pre-test, then the intervention, and then a post-test. And then there's a control group, so another group of people that don't get the intervention, they just take the pre-test at the same time that the other group takes the pre-test. They do not get an intervention, but then they do take the post-test, just like the other group did. This allows you to really rule out some other factors that a pre-experimental research design cannot. So if you recall, in the pre-experimental design, we just did pre-test, intervention, post-test. And if we stick with the smoking example, we went from 12 cigarettes to 6 cigarettes. Well, what if this other group also went from 12 to 6 cigarettes, even without the intervention? Well, then we might wonder, well, clearly it's not our intervention that caused a decrease in the consumption of cigarettes. Maybe at the same exact time, there was a national campaign that was put out there that was really hitting hard with smokers and really prompting them to reduce their cigarette consumption. So in that case, what we know now is that it was really that national campaign that that led to the changes in smoking habits, not necessarily my intervention.